Hi there. Now that we've learned how to solve quadratics, what we like to do is set up scenarios where that quadratic would actually happen. And so there's a lot of problems in this lesson that talk about integers and their relationship between each other. So I'm hammering through a bunch of examples here. And so I'll start off and I'll go through them entirely, and then I'm going to probably then start just getting them set up for you, and the factoring part of it maybe I will fly through very fast. All right, so here's one. It says the product of two consecutive even integers is 440. Find the integers. All right, so the product means that you need to multiply. That's what that word product means. You're going to multiply them together. Two consecutive even integers. So that'd be like 8 and 10. Or 22 and 24. Those are consecutive even integers. Now notice that the difference between those is always going to be 2, because you're talking about even numbers. And so that difference is 2. What I'm going to do then is call one of my integers x, and I'm going to call my other integer x plus 2, because that's the difference between them. All right, now it says that the product of these is 440. So I'm going to multiply these together and set it equal to 440. I'm going to have to distribute. So these all kind of set up to a scenario where you're going to end up taking an x times an x in some way, and you're going to end up with an x squared plus 2x equals 440. Now, when you get rid of your parentheses and you have your quadratic and you have these terms all over the place, you want to bring everything over to the same side. So I'm going to subtract this 440 over to this side, and I'm going to set it equal to 0. So x squared plus 2x minus 440 is equal to 0. So that's how we get to this nice quadratic that we're used to factoring. So let's set up our factors. It's going to be x, and I am needing two numbers that multiply to a negative 440, but they're going to add up to a 2 somehow. So if it's going to multiply to a negative number, then one will have to be positive and one will have to be negative. And if I do that, one's positive and one's negative, then, and still somehow get this sum of 2, my two numbers are going to have to be really close to each other. So I know you've already done factoring. I'm going to spend a little bit of time on these early ones and go through that thinking process on factoring. And then, like I said, I will move pretty quickly later on. So I have to find two numbers that multiply to 440. So the first thing that jumps out at me is a 444 and a 10. That would multiply. I would need one of them to be negative. Let's make the 10 be negative. But when I add those together, I'd end up with a 34. Okay, that's way too large of a number. So I need this 44 and this negative 10 to be a lot closer to one another. So instead of a 44 and a 10, let's bring that 44 down. And while we bring the 44 down, the 10 will probably go up. How about a 22? I bet 22 goes into it. So you can always check in your calculator and take your 440 and divide it by 22. And what do you know? That goes in there 20 times. One of those numbers needs to be negative though. Now since I want it to add up to a positive 2 here, I'm going to have my 22 be positive and my 20 be negative. Now those two numbers would multiply to get me my negative 440, and they add up to 2. So let's set up our factors then. We're going to put in a positive 22 and a negative 20. Once you have it factored, you set those each equal to 0. Oops, minus 20 equals 0. So subtract 22 on both sides. Add 20 on both sides. Now we have two possible answers here, and you have to be careful because the way that the question is asked at the very beginning is important on what you really want to consider your answer. So this just says that I had two consecutive even integers. So both the negative 22 and the 20 are even integers. It didn't specify that it had to be positive or anything like that. So I think these are both valid answers. Now, remember that what I have found is just the x. I have found this answer, this number. I also have to find this number. That's the other one. So when it says find the integers. So my integers could be, the first one would be a negative 22. And if you take negative 22 and plug it in right here, and take negative 22 plus 2, that actually would get us a negative 20. So negative 22 and negative 20 would be two consecutive even integers that happen to multiply to 440. Or another option would be for x to be 20. Now, if x is 20, and then you go plug it back in right here, the other number would be a positive 22. So another way to set it up would be to say 20 and 22 are solutions. So we have two possibilities here. All right, let's keep going. This one says one number is 6 more than the other. Their product is negative 9. So one of the numbers we'll call x. The other number is 6 more than that, x plus 6. Their product is negative 9. That means I'm going to have to multiply them together. And another one that you have to distribute. So x times x is x squared plus x times 6. And then again, once you have the parentheses gone, you want to bring everything over to the same side. So I'm going to add my 9. So I'm left with x squared plus 6x, plus 9 equals 0. So now this is way easier to factor. I'm looking for numbers that multiply to 9. Notice that it's a positive 9, so my signs will have to both be the same. I want to multiply to 9 and add up to 6. All right, that'd be a 3 and a 3. So I'm going to put a 3 and a 3. The signs have to be the same, and since I want it to add up to a positive 6, they would both be plus. Now you set those each equal to 0, but the thing is, I'm going to get the same answer both ways, so I don't know that I need to do it twice. When you subtract the 3, you get x to be negative 3. So it doesn't really say what the question is. I'm guessing they want to know what the numbers are. So I'm going to say x is negative 3. And then you take that negative 3 and you plug it back in. That's this number. Now I got to plug it in over here. So negative 3 plus 6 would get me a positive 3. So negative 3 and positive 3 would be my two numbers. All right. Now, this one, every one of these is worded a little bit differently. If you need to fast forward to the type of question you're looking for, feel free. You won't hurt my feelings. Okay, find two consecutive odd integers such the sum of their squares is 130. All right, so let's start with this first part. Two consecutive odd integers. Some examples of that might be like 5 and 7. Those are consecutive odd integers. Or 15 and 17. Those are consecutive odd integers. Notice it doesn't matter that they're odd. The difference between odd integers is still 2. It doesn't matter that it's even or odd. The difference between those is 2. So I'm going to go back and I'm going to say, all right, I've got x, and the next odd integer is an x plus 2. All right, let me get rid of this so it doesn't get in our way later. All right, so it says the sum of their squares. Okay, so that means I need to square them, and I'm adding the sum of their squares is 130. All right, so now this is a little trickier because I have this binomial, these two terms being squared. This x squared is fine, plus, but I'm going to take this x plus 2 that I'm trying to square. I have to write it twice, and I have to multiply it together. So when you do that, I think of it like FOIL, where you're taking the first times the first, and then you multiply the outer, then you multiply the inner, and then you multiply the last. And you end up with an x squared plus 4x plus 4. All right, now I'm going to bring this other stuff down. This x squared is still here, and it equals 130. All right, now let's go ahead and clean up the left side. We've got some like terms that we can combine. Plus, I'm going to want this to equal 0, so I'm going to subtract the 130. So an x squared plus another x squared, that's going to be a 2x squared, plus the 4x, and then I have a 4 minus 130. So that's going to be a negative 126. Now what's also new on this is that I think that when I look at this quadratic, notice how they're all even numbers? I'm going to factor a 2 out of that. That will make my life easier here in a minute. If I factor a 2, that's the greatest common factor that I can pull out of this. And I'm going to divide everything by 2. It brings my numbers down, and this will be easier to factor. So that 2 is here. I'm looking for numbers that multiply to a negative 63. And we'll add up to positive 2. So negative 63, the first thing that jumps out at me is 9 and 7, which seems to be appropriate because they have a difference of 2. Now, I do want a negative 63, so one of my numbers is negative. And I want to end up with a positive 2 out of it, so I'm going to make my 9 be positive and my 7 be negative. Once you have it factored, you'd set everything equal to 0. Now, I haven't had this number out in front. I could set 2 equal to 0, but that doesn't really make any sense. 2 does not equal 0. That's not going to get me anything. Now, if there was an x with that 2, then I could start doing something with it. But it's not. If it's just a number, it's going to end up going away. So my two solutions will be 7 and negative 9. Now let's look and see what they said up here, if they were picky about whether it was positive or anything. It said 2 consecutive odd integers. I think we're okay with both of those being possibilities. Again, if it said 2 positive consecutive odd integers, then I would have to eliminate negative 9 as an option, and I'd only have the one answer. But not the case. So I'm going to go with 7. And, okay, that's what my x is equal to. Then I have to take that 7 and plug it in up here. Remember, it's consecutive odd, so I'm going to add the 2 to it. So the other number must have been a 9. Another option, a negative 9. And, again, if you take your negative 9 and you plug it in, because it's the next odd integer, so add 2 to it, negative 9 plus 2 is negative 7. So those are our options here. All right, one number is 2 more than another. The difference between their squares is 32. What are the numbers? All right, so I think I'm to the point now where I'm going to kind of probably pause the video and I'll finish factoring on my own and just flash the answer on the factoring to you, because I have a feeling maybe we need more help with the setup on this than the actual factoring. Okay, one number is 2 more than the other. I feel like I've done this a bunch. It's the same old deal. There's an x, and then there's an x plus 2. The difference between their squares, okay, so I have to square them. And this time they ask for the difference, so I'm going to subtract, is 32. All right, this is a little bit sneakier. Because of this minus sign, I am subtracting this whole deal, okay? Keep that in mind. I have to subtract all of it. So I'm going to have this x squared here. And then I'm going to have this x plus 2 that I have to square. So I multiply the first, outer, inner, last. This should look familiar. So that all becomes x squared plus 4x plus 4. But I have to subtract all of that. All right, which means it's going to mess up my signs. This minus sign, if I'm subtracting all of it, I have to subtract every one of those terms. So it's going to be x squared minus x squared minus 4x minus 4. I have to subtract all of it, equals 32. Now, that's not all bad, because look what happens. I have a positive x squared and a negative x squared. Those two guys are going to cancel out. That actually worked out pretty nice, because now it's not really even a quadratic anymore. The x squareds went away. Now I just have the x sitting right here. It's the only x there. Let's just isolate it. I'm going to add 4 over here. I don't have to factor on this one. I got a negative 9. And again, they want to know both numbers, so take your negative 9. You got the x, now add 2 to it to get the other number. So the other number would be a negative 7. Negative 9 plus 2 is a negative 7. All right, let's keep. Okay, here's one. Consider 2 consecutive, notice it says positive integers. Okay, so at the end, if I end up with a negative answer, I'm going to have to cross it off because they want these to be positive. So I got 2 consecutive positive integers. 2 consecutive positive integers. That would be like, I don't know, 9 and 10. Consecutive positive integers. Might be 23 and 24. Now notice that on these, the difference is only 1. If I'm doing evens or odds, the difference is 2, but here it's just consecutive integers, so the difference is only 1. So I'm going to have an x and an x plus 1. Those are going to be my 2 factors, or my 2 numbers. Okay, 2 consecutive positive integers, such that the square of the second integer, ooh, this is lengthy, okay, sorry. The square of the second one, so that's what I'm going to have to do there, added to 6 times the first one. Oh, I got to take this one times 6. Is equal to 85. All right, it's a little messier. Let's do this x plus 1 squared business. Oops, don't square that. That's kind of redundant. Okay, multiply first, outer, inner, last. Middle terms combined, so I get an x squared plus a 2x plus a 1. But I still have the 6x out in front that I'm adding. And I don't mean, I'm doing this in a different color so that that part stands out. You really should keep your 6x there so you don't forget that it's there. That should stay out there. And you can leave your equals 85 so you don't lose track of what the rest of this equation is. I just know that multiplying those two together takes some extra work, so I kind of show that separate. All right, I'm ready to, I can see this is a quadratic. It's got this x squared term, but I think I could combine this 6x with this 2x. Those could just combine together. And then I can subtract the 85 over so that I can get ready to factor. All right, if you need to pause the video to see how I did my factoring and make sure that you get your answer, you can. Otherwise, I'm keeping on. Okay, now I'm done with the integer problems. Now I thought I'd throw in some of these other ones. It says the height of a triangle is 7 centimeters greater than the base. So you have some sort of a triangle here. And the height, which comes always perpendicular straight down from a vertex, that's your height right there. That height is 7 centimeters greater than the base. And the base is down here. I don't know what the base is. I'm just going to call it B for base. But what that would mean is that the height would be 7 more than that. So I'm going to call the height B plus 7. Now you do need to know your area formula for a triangle. It's probably on the formula sheet though, so you can always go back to the formula sheet. You'll have that for the test. Okay, so let's fill in what we can. It says the area of the triangle is 39, so I already know the area equals 1/2. The base of my triangle is a B, but the height of my triangle is B plus 7. Now there are different ways to do this problem. And I guess that 1/2 certainly is going to make this a little trickier. So what I would tend to do is I would get rid of that 1/2 right off the bat by multiplying by its reciprocal. But I have to do it on both sides of the equation. So if I take it times 2/1, what's nice about that is the 2's would divide out. But I have to take the other side times 2/1 also. Now this side's not a fraction, so I don't really need the over 1 part. And I just do 2 times 39, and that's 78. Then I'm going to have the B and the B plus 7 over here, but the 1/2 is gone, and that's going to make my numbers way prettier. Let's distribute. All right, looks like this one's a quadratic because you have the B squared, so let's make it equal 0. I do like to keep the B squared positive. So I don't want to bring things to the left. I want to leave this where it's at. I'm going to bring the 78 over here. It doesn't really matter which way you're going as long as you get it all on the same side. So what I end up with is a B squared plus a 7B minus 78, all of that on one side, and it equals 0. And I put my equals 0 on the right. I could have put it on the left. All right, so on this one, after I got done factoring, I have two options for B. It could be 6 or negative 13. Now, in this particular example, it doesn't say that it has to be positive, but it is sort of implied because it's a triangle, and B represents a length, and it wouldn't make any sense to have a negative length for your base or your height. So you do have to X out the negative answer on that, and we only want the 6. Okay, so it looks like then the base of our triangle is going to equal 6 centimeters. And if your height is 7 more than that, then it would be 13 centimeters. All right, let's see what this one says. It says an architect wants to draw a rectangle with a diagonal of 13 millimeters. The length of the rectangle is 2 more than twice the width. Oh, okay, so that's a little bit wormy. They talk about the diagonal. I'm going to draw a picture, I think. Here we go. We want a rectangle. It did say that the diagonal is supposed to be 13. Now, it's talking about the length, and they're comparing it to the width. The length of the rectangle is 2 more than twice the width, except I don't know what the width is. It doesn't tell me the width. But since that's what I'm comparing it to, I'm going to call the width W. And then I'm going to look at this statement one more time. The length, so that's this measurement here. So I'm going to write an expression right here for the length. The length, but I don't want to call an L because that would give me a second variable, and then I don't want to do that. So I'm just going to write something in terms of this W. The length is 2 more than, that implies I have to add 2 more than twice the width. Well, twice the width would be 2W, but it's 2 more than that, so it would look like this. Now, what they want you to recognize here is that what we have is a right triangle, where you know something about all 3 sides. They're going to expect you to use the Pythagorean theorem. That's one of the formulas from this unit. So a squared plus b squared equals c squared. C is always your hypotenuse, or your longest side. It's the side that's across from the right angle. So right here's the right angle. This is the longest side. This is the hypotenuse here, this 13. That's what I'm going to put in for C. Otherwise, the A and the B, those are just legs, and they're kind of interchangeable. So I'm going to call A the W, so I'll do W squared, plus the B, I'm going to call 2W plus 2 squared, equals 13 squared. That's our Pythagorean theorem. The square of the legs, so one of them came out nice, the W, the other one's kind of a messy quantity. I'm going to change up my color like I usually do. I'm going to have to just go ahead and square this by foiling it together. Okay, so when I multiply first, 2W times 2W is 4W squared. The outer is a 2W times a 2. Inner is a 2W times a 2. Last, get me a 4. I don't know if you've noticed this yet. I think I'm going to take a minute to do this. This might be something, if you're starting to get the hang of this, you might like this little shortcut. But look at what happens every time. And you can look back at all of our examples. But if I'm trying to take a binomial here and I'm trying to square it, the first term is always going to be this term here squared. So 2W, I'd square the 2, square the W, it's a 4W squared. Your last number always ends up being the last number squared. So 2 squared is 4. And your outer and your inner always match. These are always the same because you end up taking the 2W times the 2 twice. So if you think of it, it's just a 2W times 2, that's a 4W, but you know there's going to be 2 of them, so it's going to be an 8W. If you can start to maybe foil that out in your head and square that binomial, that would be awesome and a little bit of a time saver for you. All right, and as always, don't forget to bring the other stuff down. And 13 squared is 169. So now I'm looking at the left side of this equation and seeing if there's any like terms I can combine. I've got a W squared plus a 4W squared. That would get me a 5W squared. Plus 8W plus 4 equals 169. That 100, now it's a quadratic, so I want it to equal 0. Let's bring the 169 over. So the final quadratic that I'm going to end up with, that I'm going to need to factor, is this right here. All right. I was hoping there was going to be a GCF to help us out here. There is not a GCF that's going to come out. So this one's a little trickier because the coefficient, oops, I didn't mean to erase that, because the coefficient on it is a 5. So when you set up your two binomials, that your factors, it's always been like WW or X and X. Now it has to be a 5W times a 1W. And that 1 is optional. I probably wouldn't typically write that. But remember that comes from multiplying the first, multiplying the first together. So these two multiplied is what's getting you this first term. Since there's a 5 there, I have to do 5 and 1. I'm actually lucky because it's prime. I didn't have options. If that was like a 12, it might have been a 3W and a 4W, or a 2W and a 6W. But 5 only has one option. It's going to be 5 and 1. Now I could have swapped those. That doesn't matter. All right, here's my bigger issue. 165. Factors of 165. But I know that when I do outer and inner, one of those factors is going to get multiplied by a 5. So that's going to build it up. It's not as simple as just numbers that multiply to 165, negative 165, that are going to add up to an 8. It's trickier than that because one of those numbers is going to get multiplied by a 5 before you want it to add up to 8. All right, so I have not done this ahead of time. I'm sorry. I'm going to do a quick, I don't know, what do you think goes into 165? I guess 5 does, right? So let's try this. If you have, I'm going to come over here with a little side note. 5 goes in there 33 times. Now remember, one of those numbers is going to get multiplied by 5, so I probably would take the 5. So let's try this. And I'm going to do this temporary. It might come back out, but I'm going to put in a 5 and a 33. And then I check my outer and my inner, and I want to somehow end up with an 8W. Now, the other thing is that we had a negative 165, so I know one of these numbers, either the 5 or the 33, has to be negative. But I'm going to just check real quick. If I do outer, I end up with a 25W, and inner is a 33W. And if I want to make one of those negative, I would make the 25 negative, so that when I add them up, I end up with a positive number. And what do you know? It works. I got lucky with my 5 and 33. This is my first guess. Okay, I've got it figured out. I need to have this to be a negative 25, and this is a positive 33. So now I'm going to set those each equal to 0. So I have, make some space over here. 5w plus 33 equals 0. I would subtract the 33 and divide by 5. This is not going to come out nice. Did they say that it had to come out nice? It didn't really say that. It's not terrible. It's a negative 6.6 for the width. Oh, you know what doesn't work about that though? It can't be negative. It's a 6.6, I could live with that, but the negative, I can't have a negative side length on my rectangle, so I'm going to cross that out. Let's do the other one. The other one is a 1w, or just a w minus 5. Add the 5. Ooh, that's way prettier. Okay, so I think my width is going to be 5. That's one of my answers. And then I take that 5 and I plug it in right here to see what the length would be. So 2 times 5 is 10, plus 2 is 12. So I think my length is going to be 12. And these measurements are in millimeters if you're labeling there. All right, there's my 2 answers. Whew, it's getting long. You can bail if you need to, but maybe the next one is the one you need. Okay, here it is. Bill uses mirrors to augment the laser experience at a laser show. Ooh. At one show, he places 3 mirrors, A, B, and C, in a right triangular form. So you got A, B, and C. They're going to create a right triangle. I got that, but I'm not 100% sure. Like, I feel like it's going to matter which one goes where. So I'm just going to draw my right triangle. And then it says the distance between A and B. Okay, so A to B is 23 more than the distance between A and C. Oh, okay. Well, I don't know what that distance is, so I guess I'm going to call that X. Can I do that? And then AB would be 23 more than that. Can I do that? I haven't even finished reading it. Maybe I should finish reading it. The distance between B and C, okay, that's my next option, is 23 meters less than. Oh, I got lucky there. So it's less than the distance between A and C. So that's X. So this is X minus 23. All right, what is the distance between mirror A and C? Okie doke. So what I'm going to have to do on this is I'm going to have to figure out where the A, B, and C go. I guess just a little bit of common sense. If I'm comparing things to the X here, X plus 23 is going to be bigger than that. And X minus 23 is going to be smaller than that. So this is sort of like the middle length. This up here is going to be the longest length. So that longest length is always your hypotenuse. The X minus 23 is my shorter length. And X is like my middle length. And the legs don't matter so much, but it is important that you put AB as your hypotenuse, since that's the longest. And if that's the case, I'm just going to put my A up here and my B down here, which means C is going to be my right angle. All right. What you're needing to do on this problem is the Pythagorean theorem. So remember, if you take your 2 legs and you square them and add them together, they're going to equal the hypotenuse squared. So one of my legs is an X. The other leg is an X minus 23. And the hypotenuse, the C, is X plus 23. All right, I'm going to use my shortcut on this. I don't know. You can write it out if you still need to, and that's totally fine. But I'm going to use my shortcut. So I'm going to take my first term and I'm going to square it. I'm going to multiply these 2 together and then double it, because I know there's going to end up 2 of those. So that's a negative 23x, but if I double it, it's a negative 46x. And then, oh, this is going to be a doozy. I got to square the 23. No idea what that is. 23 squared. 529. Now, when you square it, it's always going to be a positive. Equals, now let's try our shortcut again. Okay, so again, if I'm going to square this, I square the first term. That's just x squared. I multiply the two numbers together and then double it. And then I square the last term. All right, now I thought this was going to be a doozy, but I think I'm going to get lucky because I'm going to do a couple things here. I'm going to combine these like terms right here. X squared plus x squared is 2x squared. Actually, you know what? I'm going to not do that. I could, it'd be fine. But I think what I'm going to do, I'm going to bring everything, it's going to be a quadratic, so I'm going to bring everything over to the same side. So this is a little bit crazy. I'm going to subtract x squared. Subtract x squared. Oh, look, those are going to cancel on both sides. But I still have one of the x squared still sitting there. I'm going to subtract 46x. Subtract it with its like term. Here's another 46x. They're both negative. That's okay. I'm going to subtract 529. Subtract 529. So that way I'm getting rid of everything on the right, and it's going to end up equaling 0. That's what I want. Let's see what's left over here. I still have this x squared sitting here. I have a negative 46x, and another negative 46x is a negative 92x. But I got lucky. The 529's dropped out. So I don't even have a constant. That makes factoring this much nicer. I'm going to factor this by pulling out an x. They have a GCF. Let's factor out an x. Then I'm left with x minus 92. Now I'm going to set them each equal to 0. So I would set the x equal to 0, and I'd set the x minus 92 equal to 0. Now, x equals 0, that's fine for an answer, but it does not make sense in my real world problem here because I can't have a side length be 0. I wouldn't even have the triangle. So I'm going to x out that option. I don't think that's going to work. But over here, when I add the 92, I think that's going to work great. X is 92. So if x is 92, it says, what is the distance between A and C? Well, how lucky are we there? Because that's exactly what x is the distance between A and C. So I would say my answer is 92 meters. Okay, we have done some great problems. Like every one is different. I couldn't pick which ones to not do because every one is a little twist to it. All right, I only have one more though. Okay, last one. This one they actually gave you the picture. How nice. Okay. A telephone pole has a wire attached as top anchored to the ground. Okay, so you can kind of see that's this wire right here that's attached. And it's anchored out from the base of the pole here, and then you have the height of the pole. Now I'm going to redraw it so it really looks like it's a nice right triangle because we're going to be doing Pythagorean theorem. Anytime we come across a right triangle, it's the first thing that comes to my mind. Let's see if we can fill in some measurements. The distance from the bottom of the pole to the anchor point is 34. That's down here. Oh, no, it is not. It is 34 less than, it says, sorry, right here. The distance from the bottom of the pole to the anchor point is 34 less than the height of the pole. Oh. So that's really what I'm going to put up. I'm going to make that be the height, and then this is going to be the height minus 34. If the wire is to be 16 feet longer than the height, okay, so that would be h plus 16. What's the height of the pole? All right, this is another doozy. Doing Pythagorean theorem, got some quantities. When I look at this, these are my two legs. The h plus 16 is going to have to be my c for my Pythagorean theorem. So I'm going to have an h squared plus an h minus 34 squared equals an h plus 16 squared h squared plus doing my shortcut, square the first one, multiply the two, and then double it, square the last one. One, 156. Always going to be positive when you square it. All right, let's use our shortcut again. If you need to write it out, I don't know, I'm just trying to hurry the video along here. You can still write it out. Okay, I'm going to bring everything over to the same side. Make sure you match it up with its like term when you bring it over. I'm kind of doing this all in one shot. Do you like to do it in multiple steps? That's okay. You can do that. So it looks like what I'm left with, those are going to cancel. So I have an h squared. I have a negative 68 with a negative 32. That's actually negative 100 h. And the 1156 minus 256 is actually 900. Okay, this is not going to be all that bad. At least the numbers look pretty. H and H. Two numbers that multiply to 900. They add up to 100. I guess 90 and 10 jump out at me. 90 and 10. My signs, since it's a positive 900, they ought to be the same sign. But since I'm looking for a negative 100, they're going to both end up being minuses. All right, let's set those each equal to 0. So I get the height is either 10 or it's 90. Okay, when you look at this, you might think, okay, they're both positive, that's all right. But if you plug them back in, look at this right here. If you had the height be 10, and this is 34 less than that, you'd end up with a negative distance on the ground. All right, can't do that. So we always have to kind of check our answers and make sure they make sense. I like 90 for an answer. So I would go with, what are we measuring in feet? 90 feet is the height of the pole, which is what they want to know. Okay, that was kind of fun, don't you think? Yeah, hope it helped.